Today, let's talk about ready system. Before your game start a match, you will probably want to make sure every player is ready. That could mean giving them a time to select their weapon, equip armor, or choose any other loadout options. This helps ensure a smoother experience once the game begins. Our ready system needs to support the regular game we previously designed, including both offline and online modes, as well as private games. Let's start with the simplest case, an offline regular game. Since we only need to handle a single player, all we have to do is wait for them to enter the waiting room, display the ready UI, and once they confirm they're ready, the match can begin. But unexpected things can always happen. Players often do things we don't anticipate. For example, in our ready system design, we have accounted for two scenarios in the offline regular games. One, where the player enters the waiting room and has confirmed the readiness, but then goes back to the entry room. And another where the player returns to the entry room after the match have already started. No matter which unexpected situation occurs, if we anticipate it and encounter it during the testing, we need to handle it. If the player leaves the waiting room after confirming they're ready, we can cancel their ready status. Additionally, when the player enters the entry room, we should hide the ready UI. And once the match has started, we will prevent players from returning to the entry room to stop them from leaving the waiting room. For online regular games, the flow is a bit different. We need to wait for a player to join, then show the ready UI on the client of those who have entered the waiting room. Once everyone has confirmed they're ready, the match can begin. However, there's additional unexpected situation we need to handle. A player might leave the game. To handle this situation, we remove the player from the player list and check whether all remaining players have confirmed they are ready. For private games, we need to wait for player to join after a game owner assigned teams. The team information is synced to all players. Then, for those who enter the waiting room and have been assigned to a team, we display the ready UI and on their client. Once all assigned players have confirmed they're ready, the match can begin. In private games, there is an unexpected situation similar to the online regular games. A player who has already been assigned to a team might leave the game. In this case, we not only need to remove them from the player list, but also from their team. Then we must check whether each team still has enough members and whether these members have confirmed they're ready. There's another unexpected situation. The game owner might reassign players to different teams. To handle this, we can cancel the ready status of for a player based on their original team assignments. And once the new team member enters the waiting room, we display the ready UI on their clients. On Unreal Engine blueprints, we start by creating a ready variable of type Boolean to represent each player's ready status. We set a replication to replicate it so that new player can also receive a ready status of that player. Next, we can create a RPC function to set execute on server to provide a ready UI with an interface for setting the ready states. This also allows us to manage the ready system through the server-side game states. At the same time, validate RPC call on the server to ensure it meets the required condition. This includes checking whether the player is in the waiting room and if it's in a private game, whether the player has been assigned to a team. We also have execute on all RPC function that sync the player's ready states with all current online players. In offline and online regular games, whenever a player gets ready or cancel their ready status, we check the server-side game states whether all players are ready. In private games, we check whether all players who have been assigned to a team are ready. That each team has at least one member. To handle the unexpected situation where the player returns to the entry room after entering the waiting room, we cancel their ready status when they enter the entry room. We also restrict players to only leave the waiting room during the phase where when the game is waiting for other players to ready. When a player leaves the online regular games or private games, we remove them from the player list and, in the case of private games, also from the team list. Then we check again whether all players in the regular games or all team assigned player in the private game have completed their ready confirmation. In the case of private games, we also need to check that each of the team has at least one player. In a private game, whenever there's any change in the team assignments, we cancel the player ready status. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show you both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash dot slash initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms, Linux, ARM64, pick development and the server and package the project, and that's it. After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file. And then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project. We can set a position update interval here to convert a WebSocket MMO system to the real time. You can change other parameter based on your use cases. After after the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result. As we can see, when a player enters the waiting room in the offline regular games, the ready UI is displayed. We can press and hold the R key for 1 second and to get ready. In the online regular games, players in the waiting room can also have the ready UI displayed along with a player list showing the current online players and their ready status. As we can see, the test user to complete their preparation. The player list on the both clients show the ready icon for the test user 2, and the weapon they selected in the display. It is also displayed. In the private game, the player list and the ready UI is displayed after the team has been assigned. When test user 1 complete their preparation, both clients display test user 1 as ready in the player list along with the weapon they selected. That's all. Thank you guys.